Let's continue talking about finding the equation of a line in standard form. And our dinosaur guy, our friend here, Charlie, he's not too impressed by our last couple solves of using slope and a point and using 2 points. He wants to know, what about a real challenge? So we've got one for you today. Here's the question. Find the equation of a line in standard form that passes through the point negative 5, 1 and is parallel to the line 2x minus y equals 7. How would we even start that? Well, let's look at some of the information given. First of all, we need to find a line in standard form. What is standard form? Do you remember? Of course you do. It is ax plus by equals c, where a, b, and c, those are integers. They're not fractions. And x and y, the x and y terms are on the left side. C is a constant on the right side. And we'll make the x term positive when we do this. So we need to get it in that form. Well, what's the form we've been used to working with? Slope intercept form. That would be y equals mx plus b. And these two are related. We know so far we've converted from standard form to slope intercept form. And today what we will look at is converting the other way from slope intercept into standard form, as that is often helpful. So let's keep these on the side so that we can look at them and reference these two equations because they're very helpful to us. So we have slope intercept form and we have standard form here. Okay, now what else is given in here? We also are given that we have parallel lines. Well, how does that help? Because what we need to find really to get an equation of a line, we would love to find a slope, we would love to find a y-intercept. With a slope and a y-intercept, we'd be all set. And so far, all we've been given is the equation of a line in standard form, and we've been given a point. Well, parallel lines, what does that mean? Let's look for just a second at parallel lines. So we'll scoot on over to Desmos and look at some graphs right here. These two lines. What is the slope of each of these two lines? I want you to take a second, pause, and see if you can count the slope. Determine the slope. All right. Hopefully you would have come up with, and I'll zoom in a little bit so we can get the boxes a little more clear here. You should have come up with, if we start here, or let's start here for the blue one. We go up 1 and over 2. Up 1 and over 2. So that would be a slope of 1/2. And if we count the red one, we would count up 1 and over 1, 2 for a slope also of 1/2. Well, what do these two lines look like? You've learned the word parallel before, right? These are parallel lines. What that means is these lines are in the same plane, and if we zoom out and make this really big, they will never cross each other. If we zoom out far enough, they'll look like one line, but you can see there's still distinct red and blue. They never get close, they never touch. So here's the equations of these two lines. Notice they have the same slope. So what can we determine about slope of lines and being parallel? Yes, if two lines are parallel, they have the same exact slope. That should make sense to us when we look at this graph. And just look what happens if I change this even just a little. If I change the blue one to 1/3, look, they cross. So if we go back to 1/2, they're parallel. Lines with the same slope are parallel. Why does that help us? Well, let's go back to our example. Find the equation of a line in standard form that passes through the point negative 5, 1 and is parallel to the line 2x minus y equals 7. Well, we have this equation here, 2x minus y equals 7. If we knew the slope of that line, then we would know the slope of the line we're looking for because they are parallel and they have the same slope. And then we have a point, and we know how to find the equation of a line with a point and with a slope. We have done that before too. So let's start by finding the equation of this line that is in standard form. So we have 2x minus y equals 7. You try that. Try to find the slope of this line on your own, and then come back and check. All right, you should have subtracted 2x from both sides. So we would have negative y equals negative 2x plus 7. And again, don't lose your negative right here. Don't lose that negative. And when you subtract to the right side, you subtract 2x from both sides, I put that term first. It's good practice to put the variable term first, but it also puts us in the form of mx plus b. All right, so we are almost in y equals mx plus b, except we need to make y positive. So if we switch the sign on everything, which is really dividing by -1 everywhere, we will have it. So y equals 2x minus 7. So that is the equation of the line that we are given in slope-intercept form, which means the slope that we are now working with is 2. Since they are parallel lines, they have the same slope. We'll check it out. We've got a slope and we have a point. We know how to find the equation of that line now. So we substitute in, right? So we would have y equals 2x plus b, and then in step 2 we plug in our x and y values, our coordinate, our ordered pair. So we would have y is 1, and that would equal 2 times -5, because that is the x value. We substituted it directly in, plus b. So we have y equals -10 plus b. We add 10 to both sides, and b equals 11. So now we have a slope and we have y-intercept, and we can write the equation of this line. So the equation of this line is y equals 2x plus 11. Are we done? No, we're not, because we were asked to write the equation of this line in standard form. And we have written it in slope-intercept form. So we have one more step to do. We now need to write the equation of this line in slope-intercept form. So let's take this equation down here. Keep it as a reference for us, because this is what we want the equation to look like. ax plus by equals c. Right now we have y and x on different sides, so let's start by moving them to the same side. So this is now converting our equation into going from slope-intercept to standard form. I am going to start by subtracting 2x from both sides, and I will put the x term first because that's how standard form is written. -2x plus y equals 11. Well, this is just about there. The only thing missing is that we need to get x positive. So we will change the sign on everything, which is the same as dividing by -1 or multiplying by -1, however you want to think about it. But let's make sure our math is clear to follow. So we would have 2x minus y equals -11. And that is now a line in standard form that should pass through the point -5, 1. Well, let's check. 2x minus y equals -11. I'm going to check in Desmos. You can try the same if you want. So I'm going to scroll on over to our graph. I'm going to turn off the examples we just looked at, and let's open up the example we just had. We had the equation 2x minus y equals 7. I believe, is that our line? Yes, 2x minus y equals 7 was the line that we were given. So we need to be parallel to that line. We were also given the point -5, 1. So let's plot both of these. So the line we were given is this blue line. And let's see if we should zoom back in here, and let's look at the slope of this line. Well, the slope of this line, we can count boxes right here. We go up 1 over 2. It should be a slope of +2, and I believe that's what we found. We'll check back really quickly. Yes, the slope is 2. So the slope is 2. So we did that right. Good. So back to the graph. And here is the point way out here that we need to pass through. So let's put in the equation for our line and see if it fits. And the equation that we came up with was 2x minus y equals 2x minus y equals -11. So let's see how that works. We'll check it out. We have an equation. It goes through both points. It goes through the point, and it is parallel if we zoom out to the blue line. So great job on that. We did a challenge. We met Charlie's challenge. So let's try one more. Those look like they are parallel for good. And excuse me, we just had someone walk in the office there, so that's what that noise was, but no worries, we can handle that. Let's turn off these. Let's go back to our solutions. So back to the notebook. We'll do one more, and we'll do this one with a little more confidence. Okay, find the equation of a line in standard form that is parallel to the line 6x minus 2y minus 16 equals 0, and it goes through the point 6, 0. All right, so it's parallel, right? So once again, we are parallel to this line that we were given here. But we don't know the slope of this line, so we'll need to put that into slope-intercept form in order to find the slope. So 6x minus 2y minus 16 equals 0. This is not how we're used to seeing it, is it? This isn't quite in standard form yet. To get it in standard form, we'd have to add 16 to both sides. So let's do that. Add 16. So we have 6x minus 2y equals 16. But we're still not in slope-intercept form. We are now in standard form. So let's subtract 6x from both sides. You've done this before. You can do this part. Don't lose your negative. Negative 2y equals negative 6 plus 16. Divide by negative 2 every term to get y by itself. And we'll have y equals 3x minus 8. So what's the slope, everybody? The slope is 5. Just kidding, want to make sure you're paying attention. The slope is 3. So our slope that we are using is 3 for our new line. Okay, so now we have a slope, we have a point, we have an x and a y value. So let's rewrite. We have y equals 3x plus b will be our new line. That's rewritten in slope-intercept form. So let's plug in values for x and for y. So y is 0. So 0 equals 3 times 6, right? X is 6 plus b. So 0 equals 18 plus b. Subtract 18 from both sides. And negative 18 equals b. So we have a slope right here. We have a y-intercept, negative 18, and we have the equation of our line in slope-intercept form. Y equals 3x minus 18. We are asked to put this line in standard form. So let's put it into standard form. Y equals 3x minus 18, and we want it to look like ax plus by equals c. So let's do that. Let's move the x over. So we need to subtract 3x from both sides. So we have negative 3x plus y equals negative 18. And now we need to make everything positive, or not make everything, we need to make the x term positive. So we'll divide by negative 1. And we will end up with 3x minus y equals 18, and that is now in standard form. So let's check this against the graph and make sure that we are indeed parallel to our original line and that passes through the point 6, 0. So we'll tab back out to Desmos, and what's neat about Desmos is it will accept the equation of a line even if it's not in standard form or slope-intercept form. So I put it in just as we saw it. Now where's the point 6, 0? That should be on the x-axis. There it is right there, and let's just verify the slope for a second. Let's see, let's start at this point right here at 3, 1, and we'll go up 1, 2, 3 over 1. So that would be a rise of 3, a run of 1, and that would be a slope of 3. And that is what we got. Good, so let's put in our equation now and verify that it's parallel. So 3x minus y equals 18. Let's try that. 3x minus y equals 18. And that's the black line, and check it out, it goes right through that purple dot right there, and if we zoom out, it's parallel, it has the same slope of 3, and we met the challenge. So a bunch of steps, but nothing you can't handle right there. You're very capable, and we'll practice some of these later, but be familiar with these two examples. You'll try them in class, and I will see you guys soon. Keep it real, Algebears.